So, evaluating limits analytically. We kind of look at them to see if we can use the limit properties. We develop strategies for finding limits that we can't just do a quick plug in a number and get an answer. We look at the dividing out technique, we look at rationalizing technique, and we look at the squeeze theorem. So some basic limits. We've got some basics here of let b and c be real numbers, let n be a positive integer. If we take the limit of a constant, it is just the constant. If we take the limit of just x and we plug in c, we get c. If we have x to a power, then it's just c to that power. Properties of limits that we've got going on: scalar multiple. If we have a non-zero number, or if we have b, which is a real number, times a function, then the limit of that is just that coefficient times the limit. If we're adding or subtracting a couple functions, then it's the sum of their limits or difference of their limits. Product, it's just the answer is the product of their limits. Quotient, it's the quotient of their limits as long as the limit of the denominator function, g of x, is not 0. And the limit of a function to a power is that limit to that power. Limits of polynomial and rational functions. Limit of polynomial function is just plug in the value for c. Plug in c the value for x. Rational function, as long as the denominator part of the rational is not 0, then it's just plug in the number and get out the answer. Limit of a function involving a radical, as long as the limit is valid for all c when the degree or the index is odd. So like cube root, fourth root, or cube root, fifth root, seventh root, so forth and so on. And it's valid for c greater than 0 when n is even. So square root, you have to be plugging in a positive number. So square root, fourth root, sixth root. Limit of a composite function: if the limit as x approaches c of g of x is L, and the limit as x approaches L of f of x is f of L, then the limit as x approaches c of f of g of x will equal f of the limit of g of x as x approaches c, which is f of L. Transcendental functions, that's your trig functions and your exponentials and your natural log. They're basic plug and play, as you can see here, and limit of the exponential is a of c as long as a is greater than 0, and limit as x approaches c of ln x is the natural log of c. Functions that agree at all but one point, that's like you've got a removable discontinuity. Strategies for finding the limit: we look to see if we can do direct substitution. We look if we can reduce the function. We look to see if we can have a table or graph to reinforce the conclusion as we go through those. Okay, doing some plug and play here. Most of these functions, none of them have an issue because we're working all with numbers in their domain. And so the first one, we just plug in 2 as the limit as x approaches 2 of x to the third. That's just 8. Here it's just 8 times 4, which is 32. Here, fourth root of 16 is just going to be 2. Here we just plug in 2 to everything and we get 18. Here we know the top's 18, and the bottom is not going to be 0, so it's 18 over 6 or just 3. Here we're plugging in negative 4. 2 times negative 4 squared. Negative 4 squared happens to be 16 times 2 is 32. 32 minus 5 is 27. Cube root of that is 3. Tangent of 3 pi over 4, well, unit circle, and 3 pi over 4 is in that top left or second quadrant, so I'm going to zoom in on the second quadrant. There's 3 pi over 4, and tangent is the sine, or the y value, over cosine, the x value. So root 2 over 2 divided by negative root 2 over 2, positive divided by negative, same number is negative 1. Limit as x approaches 2 of e to the 3x. We just plug in 2, e to the 6 is what we get. Now in the last one, we've got a piecewise function. As it approaches -3, that means it would be around there from either side because it's everything but -3. And so from the left and from the right, we can just plug in the -3. That's -27 plus 2, which is -25. That's what it will be approaching from both sides. Dividing out technique or rationalization. So dividing out, we take the limit as x approaches 2 of that rational function x squared plus 2x minus 8 over x minus 2. And we factor out the top. And notice we have an x minus 2 top and bottom, because if you notice, I can't plug in 2 because I get 0. But right here, I have those common factors. I can cancel them. And so I've got a equivalent function, limit as x approaches 2. Now I can plug in 2 and we get 6. On the other one, I can't plug in 0 because I will have 0 over 0. But we can rationalize. Well, who's got the radical? The numerator. So the numerator is who we're going to rationalize. So we use that difference of squares concept going on. So we've got square root of x plus 25 minus 5. So we're going to multiply top and bottom by square root of x plus 25 plus 5. So number divided by itself is 1. That's all we're multiplying by. That top, we're going to have square root of x plus 25, that quantity squared, minus 5 squared. The bottom, I'm just leaving them separated, as you can see here. That top gets us x plus 25 minus 25. The 25s are going to cancel. So I've got an x top and bottom that cancels. Now I can plug in 0. And that's going to have us 1 over the square root of 0 plus 25 plus 5. That's 1 over square root of 25 plus 5. It's 1 over 5 plus 5, which is 1/10. Squeeze theorem. What we're looking to do is not sandwich them, but actually look at two functions on either side that kind of squeeze in between them, as you can see in the picture. So we start, although f of x equals x times sine of 1 over x is a product, we can't use the product rule since the limit as x approaches 0 of sine of 1 over x doesn't exist, but we can sandwich in between. However, since sine of 1 over x, a sine function, the lowest value you can have is -1, the highest value you can have is 1, we've got the absolute value of sine of 1 over x is going to be less than or equal to 1 for all x not equal to 0. We can multiply by the absolute value of x. So x times sine of 1 over x. Sine of 1 over x is between -1 and 1 is what we had going on. And we just multiply it by negative absolute value of x on both sides. And then, because the limit as x approaches 0 of absolute value of x is 0, and the limit as x approaches 0 of negative absolute value of x, which is the same as -1 times the limit as x approaches 0 of absolute value of x is 0, we can sandwich in between. And we can apply the squeeze theorem to conclude that the limit as x approaches 0 of x times sine of 1 over x is going to be 0 also. Developing strategies, well, one of them is you've got to know the different things that we've got. So we've got 3 special limits that you need to learn to recognize. Sine as x approaches 0 of sine x over x is always going to approach 1. The limit as x approaches 0 of 1 minus cosine of x over x is going to approach 0. And the limit as x approaches 0 of 1 plus x to the 1 over x is going to approach e. So finding these limits, we got to kind of make them look the same. Notice I've got a cosine of x, 2 minus 2 cosine of x. So I need to see if I can't get this. So I start with, I can factor out a 2 on that top. And I can pull the 2/3 out, so the 2 on top and the 3 on bottom. Now I've got 1 minus cosine of x over x. Remember, the limit of a product is the product of their limits. So I can take the limit as x approaches 0 of 2/3 times the limit as x approaches 0 of 1 minus cosine x over x. Limit as x approaches 0 of 2/3 is 2/3. The limit as x approaches 0 of 1 minus cosine of x over x is 0. So the whole thing is 0. On B, tangent of 4x over 6x. Well, tangent sine over cosine. So I rewrite that. And separate, I can pull the 6 out from the denominator, so that would be a 1/6. And I can, that's 1 over x, so I can just multiply by 1 over x. And then here I put the x with the sine of 4x, and then I still have times 1 over cosine of 4x. I need this to be sine of 4x over 4x. So I multiply top and bottom right here by 4. And I can leave the 4 on the bottom, pull the 4 on top out. So we have 4 over 6 outside times the limit as x approaches 0 of sine of 4x over 4x times 1 over cosine of 4x. Now I can start actually calculating it. So I got 4 over 6, limit as x approaches 0 of sine of 4x over 4x is 1, and limit as x approaches 0 of 1 over cosine of 4x, well, cosine of 4 times 0 is cosine of 0, which is 1. That's why it's 1 over 1. And 4 over 6 reduces to 2/3. Now you're trying it on your own.